This should be the last video, video 10 for chapter 11. We have just finished two-way ANOVA for the 4 suppliers and 2 looms. So we had 2 factors there, and the conclusion of the analysis was that factor B, the parachutes, was a significant factor influencing the tensile strengths of the parachutes. When this happens, we are directed to conduct what is called a post hoc analysis, multiple comparison procedure. This is going to be a simplified task because this multiple comparison analysis, this Tukey procedure, will be almost an exact copy of what we did for one-way ANOVA, with one exception: the number of data points, that is the number of parachutes tested, is twice the number that we had in one-way ANOVA. So we have 40 parachutes. Therefore, the means that were used for Tukey procedure in one-way ANOVA will not work. We'll need to come up with new numbers. Let's just read the text and move on to the procedure. If there is no significant interaction effect, which was determined previously, you can determine the particular levels of the factors that are significantly different by using the Tukey multiple comparison procedure. See references 8 and 9. Equation 11.16 gives the critical range for factor A. Here it is. This is the equation. Let's give it a little nice red frame so we know we've looked at it. Here we go. Critical range. We are familiar with all these terms here. Q sub U is the upper tail critical value from a studentized range distribution, which we actually found on the internet, having R and RC times n prime minus 1 degrees of freedom. That's for factor A. That's the looms, the type of looms. We have 2 levels of factor A. And the next equation gives us the critical range for factor B. That's the suppliers. Which supplier to choose? We have 4 levels for factor B. To use the Tukey procedure, return to the parachute manufacturing data. And as I mentioned, we're going to have 40 values there on page 441. In figures 11.10, the ANOVA summary table for Microsoft Excel, they should have said two-way ANOVA summary table. Only one main effect is significant, and that was the supplier. That was factor B. 2 main effects here were the brand, that's the loom, main effect A or factor A, also way A. In two-way ANOVA terminology could be very confusing. And the other main effect, other factor, other way, that was B. That was the supplier. Using 0.05 significance level, there is no evidence of a significant difference between the 2 looms, so we're going to exclude factor A, that comprise factor A. But there is evidence of a significant difference among the 4 suppliers that comprise the factor B. Thus, you can use the Tukey multiple comparisons procedure to further analyze differences between the suppliers of factor B. Because there are 4 levels of factor B, there will be 6 pairwise comparisons. just like we had before. Now, this strange notation is not explained by the authors. Point, 1 point. This has to do with two-way ANOVA. I think they're just trying to distinguish the multiple comparison in this part of the text with the previous one. What we're going to do is to use what they supplied us with. We're going to see the difference between the PHStat2 procedure and the file designed for us by the authors of the book. And finally, we're going to use SPSS to see how the different types of software operate when we need to run the comparison. Let's start. We're going to have to go back and check these numbers so we see that the software is doing the same thing and it comes up with the same numbers. Here are the data, and what makes it easier or funnier is that we're only going to use the suppliers. We're going to leave out factor A intentionally, which pretty much makes it the same operation. The Tukey-Kramer procedure here will not even allow us to do the entire two-way ANOVA type analysis for both factors. As usual, we're going to select the range here. And first cells contain label right here. We're going to title it Tukey for two-way and click on OK. Now it's telling us to look up the statistic and enter value in cell B15. We see right here that the denominator is incorrect. Since PHStat2 had no idea we were trying to look at the data used in a two-way analysis of variance. So they gave us the one-way analysis degrees of freedom. In doing so, PHStat2 created its own ANOVA tab, which we are not going to use. That's where it's coming from, right here. This is C14 here. C14, we cannot use this. We cannot possibly use this, but we can check the means. Let's make it a little larger. We can check the means before we go any further. So click on data. The means obviously will be created by using the average command. And 18.97, let's see what we got there. This looks correct. Tukey-Kramer, yeah, these are the means that we have. Also, the sample sizes are correct. This is incorrect. Also, the number of mean squares within, that's the error part, it does not correspond to what the authors put here in the book. Because, again, we have, let's see, 7.86 and they have 8.612 because this was calculated for the two-way analysis with the degrees of freedom that were necessary for the two-way analysis. So we're going to have to abandon this and go to the CD that was supplied by the authors and use their file designed for 4 levels. 4 levels of factor B. Let's copy this and get it over. It's already here. Okay. Same file. Now we need to fill all these cells in. Yeah, that means From here we can actually do that. Let's try to grab this, see what works. Yep, that worked. 32. And MS within has to come from two-way ANOVA, not this one. That's the correct number for degrees of freedom. This is the two-way ANOVA we did in the previous video. And this number is what we're going to use for error calculation right here. Key statistic, we're going to check on the internet for 32 and 4 at 5%, 0.05 level. Once again, we're using the same website, just to make sure that both videos have the same address, and we're using 5% table. 32 and 4. .832. Okay, let's see what the book used. They used 3, 4. Okay, critical range is what we're going to be looking at. 3.556 is close enough to what the book is showing. So we can see that the real non-negligible difference is found in group 1 to group 2 and group 1 to group 3. If we look at the data, that's here and here. So we need to pick the largest. And it's definitely here. These two significant differences, this one and this one, lead us to select supplier 2 because obviously it has the highest tensile strength for its fibers on both looms. And the critical range was less for this situation. Oh, actually, I was wrong. This was the only different one, group 1 to group 2. Group 1 to group 2. So it makes it easier to pick supplier 2. Group 2 is supplier 2. You don't have to think about anything else anymore. Very good. They conclude by saying, because 4.93 is greater than 3.56, let's see what we had here. 4.93 exactly, right here. Only the means of suppliers 1 and 2 are different. You can conclude that the mean tensile strength is lower for supplier 1 than for supplier 2, but there are no statistically significant differences between suppliers 1 and 3, suppliers 1 and 4, suppliers 2 and 3, and 2 and 4, and 3 and 4. So that's the long ritual which tells us exactly what we already know. The highest tensile strength was shown by the fibers from supplier 2. Note that by using alpha of 0.05, you're able to make all 6 comparisons with an overall error rate of only 5%. Okay, this was done for the Excel add-in analysis. Now, in more advanced courses, you will not be allowed to use Excel. So we need to create the data that will be usable by SPSS. And that's when it becomes really different. So what we need to do now is to separate suppliers and align the data in a way that can be put into SPSS. So supplier actually will have to be the name of the variable, and here we'll have only the codes. We coded our suppliers 1 and 2, and that's how SPSS will want to see that. Actually, this is correct. This was supplier 1. Supplier 2. Five values. Supplier 3. And we have to make some room for supplier 4. And let's forget, just put this in front of our eyes for the other loom. Supplier 2. This exercise makes it easier to see how the word level is illustrated in the data set here. Last one. These data are now ready to be put into SPSS. That's how cumbersome it may become. Actually, let's make a new file here. It'll be easier for us. Kill this. Variable view. We're going to have to rename the variables. This will be the loom, and we want for it to be string. Second one is the supplier. And this is strength. Tensile strength. Okay, it's refusing to accept. No, it's not. Okay, very good. Okay. First 20, so we need 19. No. Yeah. Okay, this is turf. Suppliers do need to be labeled, but we can try to get by without them. Let's see if it works first time. So we have two levels of factor A, Jetta, and Turk. We have four levels of factor B. And we have the dependent variable, which is tensile strength. Now, we need to run a two-way ANOVA in this way here. This is our dependent variable. And these are fixed factors. We can ask for, see how much you need to test, and estimated effect size. Descriptive statistics could be useful, let's use that. And the plots, what we're going to do is to have suppliers on the horizontal axis and loom for separate lines. When it asks for separate lines, that'll be the labeling of the graphs. We need to add this supplier by loom graph here to continue and see what happens. Okay, let's look at our plot first. Ooh. Well, there is a little bit of an interaction there, but it's not significant. As we can see here, loom by supplier. This is the third null hypothesis. Two-way ANOVA analyzes three sets of hypotheses. First one is the null due to factor, the null of equality of means for tensile strength due to factor A, that's the looms. Second was the equality of means due to factor B, that's the supply, and we can see we reject that. The means are not equal there. And the interaction right here of loom and supplier is not significant. We pushed out of the rejection region. Nonetheless, there is some sort of an interaction here between 3 and 4, but it's not significant. All we need to do now, let's save this. Okay. R squared, that's the square of multiple R. That's the correlation between predicted value of the dependent variable and the actual one. Okay. And here's the eta squared. That's what we requested there. So we got a little effect size for the interaction. Here's the Levin's statistic. We do not reject the hypothesis of equality of variances, which is good. Now this is a little strange. Why do we have something happened here? I see. Let's go back. It should be Jetta. That's why. That is why. No, this makes sense. Let's see what you calculate, so we need to rerun. Let's rerun. Okay. Analysis. Now this makes sense. We have 20 and 20 as we should. And now the plot makes perfect sense. Very good, very good. So that was a mistake, by the way, very, very illustrative of the fact that data entry is a very common cause for mistakes. Okay, I'm glad I captured that on video. Very good. Okay, last thing I had to do was compare the analysis results here, two-way ANOVA, with what we've got here. Okay. F 0.809, 810 is pretty close. Okay, these are all good numbers. At least these two software packages agree on what they're doing with the data. That's very, very good. 417.2. Okay, factor A. It's easier to see here in SPSS actually. We have loom and supply. We have to figure out the sample and columns. So good results. We are happy. End of chapter. End of chapter 11.